Good afternoon, everyone. My name is Jin, and I am CAE consultant and technical support engineer here at Microsoft. Welcome to our 7th Elite Training Series. Video and PDF version of this presentation will be updated on our North America Microsoft webpage. Please feel free to access at any time in future. Today's topic is moving load analysis. I'll be explaining different functions of MIDAS Civil with moving load analysis, different analysis approach used in MIDAS Civil, visualization of analysis results in graphic and tabular format, and responses to frequently asked questions from users. Before we go into the presentation, please feel free to throw me any questions. I won't be able to answer them one by one during the presentation, but I'll gather them and then personally answer them and get back to you as a whole. As a group email, I'll follow up after the presentation with the questions. So feel free to throw me any questions or type any messages in the chat box. Here's the list of items that will be dealt today. I'll start from moving load lanes, types and application method for moving lanes, vehicle loads, accessible vehicle loads in database and user-defined loads, moving load case, creating case-specific moving load case, meaning creating project-specific moving load case, analysis result and visualization, possible analysis result applications. Now I'll start by covering moving load lanes. Just out of curiosity, everyone's hearing me clearly, right? Please raise your hand up once again. All right, thank you. In MIDAS Civil, moving load lanes can be applied to girder or deck elements, but to replicate the load distribution behavior at the most realistic approach, it is recommended to apply load directly to deck elements. In MIDAS Civil, deck elements are recommended, well, mostly beam elements and plate elements are used for deck elements. So therefore, we have two different types of moving load lanes. Depends on the deck elements type, applicable load lane types are different. For beam elements, traffic line lanes are being used on the top. For plate elements, traffic surface lanes are used. It determines the load application method on elements. Line lanes are mostly in form of uniformly distributed loads, when surface lanes are pressure loads. Load distribution method determines which set of elements are directly under applied moving load. When the lane element is selected on the right, the reference girder elements for load lanes will be the origin of the moment arm, and resulted moments and shear will be directly applied to the reference elements. It's clearly described in the picture right on here. I directly copied this picture from our online help manual, which user can access by pressing F1 with MIDAS Civil open on the window. I'll continue with the presentation. When crossbeam distribution method is selected, as you can see, the applied loads are directly applied to beam elements, which is crossbeams. And when users activate the crossbeam, the user can select which beam group. This beam group can be defined in the structural group, and the applied moving load is directly applied to the beam elements, and then it's transferred to the girders and then to the support. So frequently asked question number 1. For more refined analysis and accurate result, I have defined deck as a plate and girder as a beam. I apply live load, but it gives me error message. There are two possible responses for there are two possible cause of error for this type of query. First, user might have applied a traffic line load with selecting girder elements. User already defined the deck element with a plate. For the plate elements, traffic surface load needs to be used, and yeah, the description is described in the presentation. And for the second response, wrong eccentricity for lanes. I wouldn't say wrong, but it's too much eccentricity. When the lanes are defined outside of the deck width or deck elements, program gives out error and that it would not proceed. Additionally, as you will notice in the program, traffic surface lanes do not have load distribution options, because for the surface lanes, deck elements are directly selected for the lane application when line lanes are based on the girder elements. There are three possible options for selecting the reference line for line lanes. First is 2 points. 2 points, user can simply select the start point and end point of the line lane. This comes very handy for straight bridges. User can just select one girder and then the start element of the girder and then the end element of the girder, and lanes. The moving load lane is automatically defined. Picking manual element selection. User can select the elements that line lane will be applied manually. Once user select the elements, it will record in the bottom window in numerical orders. Third option is element number input. It's same as picking, but once you define the structure group, program will tell you the element numbers for the structure group. You can simply copy that and then input in the number window, and then line lane will be automatically generated. The lane direction. This determines the direction of applied vehicle load. Forward meaning it's going to follow the numerical order. Backward is going to come back. It's going to move in backwards. In both direction, program will consider both cases for forward and backwards. Frequently asked question number 2. When I choose backward for moving direction, does it change the list order of selected elements, or does it just change the direction? As I explained in the previous slide, it doesn't really change the numerical order of the elements. It only changes the direction of the vehicle. Traffic lane optimization. This feature enables program to allocate vehicle loads on both edge of assigned traffic lane to consider the worst case scenario of moving load case. When this function is activated, user can also modify the loaded lane width. It is not fixed at 10 feet. User can freely modify the lane width. However, it does not automatically consider the safety offset from edge of the design lane specified in AASHTO 3.6.1.3.1. I believe it's for the 2 feet for exterior girders, exterior barriers, and 1 feet for inside or the other. Yeah, it doesn't. The program does not automatically consider this, so user can freely modify that safety offset by using the eccentricity when defining the line lane or surface lane. Frequently asked question number 3. Is traffic lane optimization as same as load floating? Traffic lane optimization is a little bit slightly different from load floating. When load floating is literally shifting the vehicle load along the lane width, the traffic lane optimization only allocate the applied vehicle load on each edge and the center of the applied lane width. The load floating is currently under development, and it will be added to the program shortly next year, I believe June or by end of next year. However, our program can also our program has some workaround approach for the load floating. It's called Transverse moving load case. I don't know how many of you have seen this feature on the moving load code, but Transverse moving load code allows user to allocate moving load in cross-sectional point of view and run analysis for maximum number of applicable lanes, the location of vehicle loads, and cross-sectional moments. One of the project application that I experienced before, I simply ran static analysis with all the dead loads, and then once you turn on the legend, you can you have idea of where the critical elements is located, and I defined this transverse moving load at the support at the pier caps, and then ran analysis and retrieved the result based on the critical element from the dead load analysis, meaning that this moving load is located. The moving load location is based on the critical element of the dead load analysis. Do you guys have any questions so far? If you have any questions by this point, please write it down. I'll pick one and then answer it, and then proceed with the slides. You'll be able to get these slides after the presentation, I'll post them online. You will be able to access this PDF format and with example project files that I'll be showing in this presentation too. Static load case. I think I may need a little more explanation on that. If you guys don't have any questions, I worked my example files in Midas Civil 2016, but for the sake of all the license, all the program versions being different, I'll post them up with 2015 version. Yeah, so it can be opened with 2015 and 16 at the same time. Okay, yeah, I'll proceed with the slides. As you already know, we have very large database of predefined vehicle loads. For ASTO LRFD codes, we have LRFD 12, standard and legal and permit loads. LRFD 2014 is currently being updated right now. It should be updated by early next year or June. We also worked very hard with DOT active users, and as you can see in below on the picture on the right, we already have 9 different DOT loads defined. This is not a single load; it's a set of loads, but just name in this way. Each of them has about 7 to 8 or even more at their how many ever meeting their need already defined in them. For the other loads, we have train loads Cooper 80. Unfortunately, we don't have ARIMA loads in our database, but we can the user always can create the user-defined loads using this window. Our user-defined loads have very user-friendly Excel layout. Either it gives user option to apply the loads as a point load or distributed load, symmetric or asymmetric Excel load, or varying spacing Excel load. User can save the Excel load information on the right, and then they can simply just select the type of Excel and make this window, fill in this window, and then the load will be automatically generated. Excuse me. Anybody have a question about the user-defined loads? MTO loads are not included in the system yet, but once we see the need for it, we'll update it and then add to the database. Moving load case. There are 2 approaches for moving load analysis. One is distribution factor analysis, and second is influence line analysis. Our program is currently using influence line analysis. There are 4 scale factors that you can assign in the program. First is impact factor, as known as dynamic allowance factor. Second is user-defined min-max number of loaded lane. Third is multiple presence factor. And last one is amplifying factor for selected load case. There's no limit on the number of axles that can be applied in the user-defined load. I'll get back to it after I go through the slides. Moving load analysis supposedly run for loaded situation for a single vehicle at a time. However, our program can consider multiple load effects. This comes useful when construction is being done adjacent to existing structure with high traffic or high pedestrian loads, or considering the intersection load. As you can see, we have two different types, independent and combined. Independent and combined. I'll demonstrate the load case after all the slides, but for this specific project file, I've defined HL93 truck and surface load for the replicating the pedestrian load. As you can see, independent gave me only the load case, which will create the maximum, the worst case scenario of between two cases. When combined, actually combined the load effects and displayed the maximum, the worst case scenario combining two load effects. Analysis result can be retrieved in tabular format as well as available for our other analysis results. When deck was modeled with plate elements, stress calculation for plate elements are also available. Moving load tracer displays the location of applied vehicle that under the worst case scenario of the applied loads. We also have something called lane support negative moment test. This is, well, we call it dual truck test. Our program has function to apply this AASHTO 3.6.131. And I will demonstrate this modifier shortly after all the slides. The fourth option is view by max. When analysis results are displayed in min, max, or in envelope form, program displays the maximum values of all categories, meaning it will display the maximum value of all. But when the view by max is activated, program asks user to pick a single component for the maximum value and calculates the other components at the corresponding case, meaning that it will not show the maximum value for all the components, but it will rather select one component for the max and then calculate the other values for at that corresponding case. So for example, when view by max is not selected, according to this table, program will show 2.5 for the MY and 0.1 for the max for FC. But when the view by max is activated, program will show view by max is activated and I selected MY as a reference. Program will show my equals to 2.5 and fz equals to minus 0.5. Okay, frequently asked question number 4. Bridge is modeled with deck as a plate and girder as a beam modeling approach. Completed analysis including moving load analysis. When I tried to check stress values for deck elements, it did not display anything. In order to consider that deck stress calculation, user needs to go to the moving load analysis control window and activate the stress calculation key. If this is not selected, it will just show just 0. It will not calculate anything for plate deck elements. Question number 5. I defined structural group for specific girder and ran lane support negative moment check. Analysis successfully completed, but result does not look correct, or it does not show anything. So prior to running lane support negative moment check, user needs to manually specify the start element for each span of the selected girder from the traffic lane properties. So in the bottom window, you will see element number, eccentricity, and then span start. So you need to manually select, click the span start in order for a program to recognize each span width. Question number 6. I retrieved analysis result data and activated view by max option. However, it did not change values in table at all. In order to display or activate the view by max analysis result, user needs to activate normal concurrent forces and stresses from moving load analysis window. Without this function activated, I don't think you have access to view by max. Even if you do, it would not show any difference on the table in the table results. So this is the end of slides. Right now, I'll jump into the program and cover one by one for the described functions in the presentation. Okay. This is just a simple how many girders? 4 girder steel composite bridge that I created using Wizard. This is all beam, all frame elements, all frame modeling approach, and I'll be showing how to define the line lane using structural group and activation and deactivate function of multi-civil. So the easiest way to define the moving load lane, the line lane for steel composite bridge, just like this case, is go to group, and program automatically generates the girder structure group. Right click it and activate, and it will only activate the girders. And go to load and moving load. As you can see, I don't have any moving load defined, and select one. Traffic line lanes, add. Let's name it L1 and 2 point. So simply click the first one and the second one, which will be the end of my moving line lane, traffic line lane. As you can see, I've selected the selected elements are listed in numerical order on the bottom window. And once you click OK, you'll be able to see the line lane defined in the program. For the project with plate elements as a deck element, I've also generated the same model using Wizard with deck with plate elements. For this case, I will activate only the plate elements and look from the top. Go to load, moving load. Let me delete all of them. Choose LRFD, go to traffic surface lanes, add, and by picking, I'll select by window and select these. Excuse me. And choose these elements, plate elements, and either you can click here and click one by one, or you can copy the element number and go to number and paste and add, and it will automatically list them up in numerical order at the bottom window. And click OK. Let's name it L1 again. And you will see this is often one of the times that users have difficulty of assigning the traffic lanes. The numerical orders are, so right now you can see the lanes are all jumping around. That was because it might be the case when you just copy the elements in numerical order. When you select the plate elements, program automatically line them up in numerical order. But when the program is generated, when program generates the structure file with plate elements, the plate element numbers are not always in numerical order. So if you don't want to have the error that I just experienced, please be careful when you choose the reference, not reference, but when you choose this, the girder elements with the plate elements. Okay, I'll jump into the vehicles. Go to standard. As you can see, for the LRFD loads, we have HL93 truck, 93 tandem, and HS20 fatigue. If I go to standard, I have all these loads. And for the DOT loads, for the others, we have Cooper 80. If you don't find any of these, if you don't, one of the most frequently asked question about the other load is ARIMA. Do we have any ARIMA lane, vehicle lanes in our system? But apparently, unfortunately, right now we don't have the ARIMA code in Midas Civil, but they can go to add user defined and select a permit truck or train load to define as many as the loads applied loads for ARIMA specific train loads. I'll open up another file for the traffic lane optimization. This is the one of the predefined model that I already ran analysis just to show you guys the traffic lane optimization results. It's curved bridge. I created curved bridge because I chose curved bridge to show the traffic lane optimization because for the straight bridges, it's very hard to visualize or select specific element that will show the different moments. The curved bridge would make it a lot easier to show the different location of the vehicle for the worst case scenario. So right now I've already ran analysis. I've defined line load along the bridge. As you can see, I've defined HL93 truck, and I go to result, go to moving load tracer, go to beam force moment, and check result for element 588, which is located the center of the exterior gutter. And activate only that portion of the bridge. As you can see, applied line lanes are being shown in the green when the actual load application is offsetted from the center of the line lane to the right to create more moments. The traffic optimization function shifted the applied vehicle load to the right, and which will create the worst case scenario of the applied moving load case. Next, I'll go into the user defined load and demonstrate the varying space option. Okay, go to the moving load, vehicles, and this is permit 1. Modify. As you can see, I only used 2 axle loads with spacing 14 feet, 50 and 100. one of the things that you need to be careful about using the varying space. So if you want to have, let's say, number 3 with the varying space, if you want to have number 3 with varying space, you need to click the number 3, not number 2. Some people get confused with which axle that needs to be activated to consider the varying space. So with number 4 activated, I'll check the results. Okay, checking results for element 15. Let me turn on the element number. So right now, the distance between third axle and fourth axle is about 50 feet. But when I check next element, the spacing increased. I don't know by how much, but so when I inputted the varying space from 100 to 50 to 100, program automatically applies that fourth anything from fourth axle from 50 to 100 feet, and it displays it displays at that it displays how whichever spacing that creates the worst case scenario for selected element. So I check 17, and when I check on the other side, it's even larger, and it comes back. So it depends on the selected elements. The varying space allows program to calculate individual loading effects and then displays the worst case scenario. It displays the vehicle location for the worst case scenario. Okay. Yeah, I'll look into ask questions. By end of this presentation, I have about one more model file to show you guys. If I cannot cover all of them, I'll gather them up and then I'll summarize the responses and send it back to you guys as a group email without anonymously. Yes. So even if I do not get to, well, I'm not answering your question right away, please feel free to ask questions in the question box. You'll get response after presentation within a couple days, definitely by next Tuesday or latest Wednesday. Centrifugal force is not currently it is not automatically applied in Midas Civil right now, but there is always a workaround approach. I do not have a specific model file to represent or demonstrate the centrifugal force application, but I can definitely include that response or workaround approach in the response email and then share it with all of you guys. Okay, this is the same model file that that I captured the image from image in the presentation when I explained the loading effect. So I go to moving load. As I said, for the traffic line lanes, I've defined two lanes. One mimicking the pedestrian, and second is the vehicle lane. And for the vehicles, for the loads, I've defined HL93 truck. And for the pedestrian, I've just applied the surface load of 0.5 kips. Seems too high for a pedestrian, but I just applied that. And for the moving load case, I've defined two, one independent, one combined. When I look more closer into it, so here you can define, here you can adjust the multiple presence factor, the scale factor that applies depends on applied loaded lanes. You can also select loading effect, combined or the independent. For now, I've assigned the pedestrian load to pedestrian lane only, and truck load to vehicle lane only. And let's look more closely into the load case. So this is how Mitre Civil looks like, and you can choose vehicle class, whichever vehicle load that you want to select from. Scale factor. This was the scale factor for selected load case. If you want to increase, if you want to emphasize or amplify the effect of this specific load case, you can always apply scale factor here. You can select the number of loading lanes for the minimum and max. For example, you've assigned 6 loaded lanes, but you come here and then when you make a load case, you select a vehicle, and then out of 6, you only want to consider 3 at max. But for the minimum, you only want to consider 2. If you choose 2, well, 3 is not a good number, but let's do 4. If you select 2 and 4, program will calculate the case scenarios and then select for the minimum number of loaded lanes. It will calculate 2. It will only select 2 lanes from assigned 6 lanes for the minimum case, and it will calculate the which 4 lanes that will generate the worst case scenario, and then it will only have lanes on 4 of 6 lanes. There was a little not organized explanation, but I will have that more explained in the response email. So this is how it was defined. For combined, everything is same except loading effect. So I go to result, go to beam forces and moments, turn the legend, and I choose whichever load case or combination that I want to take a look at. Here you can see min max envelope. Let's go to max, or let's use just moving load tracer. I'll simply select just 593 and apply. So program compares between two load cases and select for independent, select whichever load case that generates the worst case scenario for selected element. So it's neglecting the pedestrian load. It's only showing the applied the truck load. But when I check the result for same element with combined load case, it considers the pedestrian load and truck load at the same time. For this specific model, I'll look into the negative moment support, negative lane support negative moment check. Lane support negative moment check can be defined in load, moving load, and lane support negative moment here. I've assigned the gutter group called let me open up some other file that can show better explanation. Okay. So back to lane support negative moment. I've defined the structure lane support group and added on the negative moment check, and go to lane support reaction and selected these two elements, these two nodes, which is located at the supports. And I go check the moving load tracer. As you can see here, I've selected I've defined the lane support reaction node on the support, and program calculates the loaded situation. I believe it's 30 somewhat distance from the supports with two trucks to same truck load applied on the both ends. Program automatically calculates the distance, and let me turn off the numbers. This value is in the influence line. I believe influence line can be, you guys can copy that into your spreadsheet and then retrieve the results. Okay. I'll pick one or two questions from questions asked and then answer that. I think we already we are good on timing. Somebody asked, is a truckload distributed to adjacent girder? So when vehicle load is applied on the deck elements are supposedly connecting the distance between each girders. The load will distribute to the girders and to the support. So it all depends on how you select. As I explained in the slides, if you select lane elements or cross beams, in order to have that effect, you need to select cross beams and then make sure you include that specific cross beam group in here. Yeah, I looked through the question list, but there were too many. I wouldn't be able to choose one. So well, this is so far everything that I prepared for this presentation. It's yes. So next presentation will be done by my colleague Sungwoo Park, who is the original organizer for this event. If you have any questions regarding this presentation or anything regarding any technical support while using Midas Civil, please submit. Please submit email to ts@midasusers.com. I believe most of you are active users already now. Yes, please send me any email to ts@midasusers.com. Well, I'm the person who's in charge of answering the questions, so I'll personally answer your question and then get back